Hi, my name is Dr. Kamba, still on series 1 of our video on time series data analysis. In this unit 3, I will be discussing the ADF and PP unit root tests in time series data using eViews statistical software. ADF is the acronyms for Augmented Dickey-Fuller, and the test is credited to Dickey and Fuller 1979, while PP is the acronyms for Philip Perron, and the test is credited to Philip and Perron. These two tests are the most widely used in the methodologies of most economic research as well as in the statistical analysis of time series data. There are other unit root test options such as the Kwiatkowski-Phillips-Mitchin, the KPSS, the Elliott-Rothenberg-Stock Point Optimal, ERS, the NG-Perron, and many others. However, ADF and PP are the most widely used in most economic studies. Now, the steps for executing ADF and PP unit root test are summarized as follows. Step 1. Arrange the variable and the data in Excel or in Word document. I choose to arrange my data on which the test is to be conducted in Excel. I have the data here. I have two variables here, inflation and GDP per capita. And data on these variables are collected from 1960 to 2020. Now, the advantage of having data in Excel is that it can be imported directly into the eViews software. That is, if the eViews software is already launched, there is a provision for importing the data directly into the eViews software. But if the data is in Word document, such provision is not available. You have to copy the data from the Word document, paste it on the work file created in the eViews software. Step 2. Okay, before step 2, the data should be arranged in column with the variable being the first entry in the column, followed by numerical data on the variable. This is very important. This is what this point is saying. The data on inflation is already arranged in column E, and of course, data on GDP per capita is also arranged in column F, and this is the year, that is the time the data on the variables were collected. In 1960, this is the data for inflation, this is the data for GDP per capita. In 1961, these are the values. So the data is arranged in column. If the data is arranged in rows, something like this, let's copy. Okay. Suppose this is our data and this data is arranged in rows. This is what we mean by in rows, like this. Okay, I'm converting it to row data. Okay, you see the period now is in row 1960, 61, 62, 63 in that order, and these are the variable. These are values on inflation and GDP per capita. eView cannot recognize the data arranged in this form. So that's why most data that are available in rows in the statistical bulletin of Central Bank of Nigeria has to be converted into a form like this before feeding the data into the eView statistical software. Now, the data should be arranged in columns. We have achieved that with variables being the first entry in the column. I think we have achieved that too. The inflation variable appear first in the column, followed by the data on inflation. Here too, GDP appear first in the column. The importance of this is that the eView recognizes this first row as the variable name if the data is fed into the eView statistical software. Suppose we delete this column, for example, or we copy this and paste it at the last. Okay, let me delete this column, for example. Delete. Okay, and suppose we now bring those variables here. Okay. Let me go back again. Let me undo. Okay, let me copy first. Copy, and I'm bringing it here to the last. I just want to demonstrate what the point is all about. Okay, now Let me delete this data from here. Delete. Suppose we have a data like this from 1960 to 2020, and then the variables come last. So if this data is fed into the EVO statistical software, this first entry, 1960, and this value will be recognized as the variable name. So this EVO software is unlike SPSS, where you have column for variable name and column for numerical values. Whatever you feed into the EVO, the first entry for every column is treated as the variable name. So that is why the variable has to come first, then followed by the data on the variable. Okay. I think I'm done with this. Okay, what is the next step? So the next step says step 2. Launch the EVO software by double-clicking on the software, create work file, and then to create work file, these are the procedures. File, new, go to file, go to new, go to work file, and click. So let's launch our EVO software. I have my EVO software in this folder. Okay, I double-click. This is the EVO 12 coming up. I'll close this icon. I don't need this. Okay, I'll also close this. I don't need it either. Okay, let me close it. All right, so this is the EVO's page. This is the EVO's page. Okay, this is the EVO's page. This is file. So the option, the step says we should go to file. And from file, where do we go? Let's check again. Step 2, launch the EVO software. We have done that by double-clicking on the software, then create a work file. How do we create a work file? Go to File, then New, then Work File, and click. So let's go to File. Where is File? This is File. Click. New, Work File, and click. Okay. So this is work file create. What is the next step? Fill the necessary information on the work file. What are the information to be filled here? Let's go back to our work file create. So these are the information. We have data, we have work file structure type, we have date specification, and we have work file name. So let's start with work file structure. There are 3 options here. The first one is unstructured/undated. This one is used for primary data. Then this one is peculiar to our study. It's used for secondary data, time series data, while this one is for panel data analysis. So we are choosing the second one, the second option. Then our data, the frequency of our data is annual. You can see that there are many options here: quarterly data, monthly, bi-monthly, and many others. Okay, it's annual. So the start date of our data is 1960 and the end date is 2020. Let me show you the data again. This is the data. Okay, I have data on inflation from 1960 to 2020. So I'm coming back here. So here I put 1960. Where is the keyboard? Okay. Okay, this is 1960. That is starting date, and then end date is 2020. 2020. All right. Okay, the last one is optional. Work file name. Okay, I am going to name the work file as Canva. K A S M M K M K M B A A. So this is my work file. We are done with the necessary informations, and this can go. All right, then I click OK. See, okay, we have work file structure. That is dated regular frequency. Our frequency is annual. Our start date is 1960. End date 2020, and work file name Canva. I click OK. So our work file has been created. You can see that in this work file, the name is Canva. The range of data is from 1960 to 2020, that is 61 observation, and also the sample size is 1960 to 2020. So the range of data must be equal the sample size. Then there are two things here. The first one is the intercept, that is C, the constant, and you see that if you double click, it is 0000 because we are yet to carry out any estimation on this page. The residual will also not be available. This is the error term or the error residual. Let me open it. You can see that everything is not available because no estimation has been carried out on this software, on this page.